Welcome everybody. In this short tutorial, I will introduce the new tool, the XGL we provide in the version 10 of our XGS Lab. This tool is OpenGL based, so it can be very powerful because it works with graphical device potentiality, and we can have a very nice rendering experience and also representing 3D objects. At the moment, we decide to introduce this CAD just for the shield module, but I believe briefly it will be available also for drawing other kind of geometry, like segment, the grid for the grounding system or other things. We decide to start with this version of our CAD just because it manages 3D shapes. 3D shapes that are useful for the shield, because these shapes can represent buildings or any kind of 3D object on your world, the world you are representing. So before to see how to create these solids, I want to have a very fast introduction of the CAD behaviors. All things that the user have to know in order to have an appropriate usage of this instrument. Most of these things I will illustrate are very intuitive, very easy to understand. So as I told you, I don't want to spend too much time on these things. Let's start with the toolbar. The toolbar, as you can see, is composed of very few buttons or control in general, because the CAD is very essential in this moment. The first thing that we note is the viewer section. So in here, in this combo box, we have a list of the full view we can have with this CAD. So we can have a view in a different way. So our wall change aspects. In this case, I change my view. As you can see, what I obtain is this, but I can change very easy. But the thing that I believe can be useful for you is to customize this list introducing new view. So if, for example, I decide to rotate this image, I choose this button, okay, and with the mouse wheel pressed, I can change my world just rotating freely everywhere. Okay, and I can freeze this view and just adding it, assigning a new name. So now in my list, I have this new view that I can recall every time I want. Okay. The same thing I can say about the delete. Delete can be applied only on the custom view. So I can remove my best view, but I can remove the default views. Okay. Then we have this button, 100 zoom, 100%. Is allow us to return our scale factor to 1. I mean, we can change the scale of our draw, rotating the mouse wheel, okay, and with the bottom 100%, we return to the 100. We restore the scale factor to 1. Okay, so another useful button is the capture image. So I can copy this image in the memory and I can paste it on Paint or in Word or everyone on every program except this kind of functionality. Every operation I do in the CAD is a combination of a state and phases. I mean, if I decide to rotate the image as we saw earlier, as you can see in the bottom left corner, we see that arc rotate text are highlighted. This means that I am in a rotation state. So moving all around, close to our arc rotate state in the status bar, I see the text phase 1. So each phase, each operation I do in our CAD as two state information, let's say these. These are represented by the state and the phase. Okay. When I press the button with the arrow here, idle, I restore the status idle, so nothing is happening at the moment. Okay, this would be useful to know when I draw. Another thing to know is that pressing the button ESC, I return to the idle state as well. Okay, so let's have a look to the other button. I have the button move, okay, with this hand icon. So when I select move, the state change became move area, and pressing the wheel, keeping it pressed, I can move all around our scene. Okay. Then we have auto rotation, so I can decide to rotate my view around the x-axis or rotate around the y-axis or rotate it around the z-axis. I have this kind of effect. Okay. Pressing the idle button, I stop everything. Okay. I can change the background. I can change the speed of refresh, of the image refresh. For example, if I rotate, the speeds are faster now. Okay. Then we have a set of buttons that are useful for the 3D shape management, and we will see these in the next step. For the moment, we continue to see what's happening all around. We have the status bar, as we saw before, with the state and phase, but we have also the coordinates where we are with the mouse inside the window. Okay. These coordinate systems are related to the specific z-plane. So if I want to have different coordinates, I refer to a different plane, I can change in the right grid in here, in the drawing section, the Z. This is our working plane. Let's say this. And now when I move the mouse, the coordinates I have are on the Z50. Okay. Other useful information in the status bar are the hovered and selected. These are two counters that tell us how many objects are hovered at the moment. For example, if I move my cursor over this segment, okay, as you can see, the counter now is 1 because it's telling us that we are over a segment. But if I, for example, go with the mouse on the cross points, as you can see now hovered is 3 because I have 3 segments in this moment, because I have 2 horizontal segments and 1 vertical segment that now are not visible. The other information is the selected counter, because if I click on the segment, I can select this segment and make something with this. The same thing we can say for the shapes. So if I select the shape and I do this pressing the Alt button and clicking on the center of the shape, okay, as you can see, the transparency is changed, but we can see this then when we will see the effect with the light. So the selected object now are 2, for example. Okay. The other information in the status bar is the scaling factor. Now it's 1, but if I zoom in, now the scale factor is 1.5, then I return back, it's 1 again, and 0.75. Okay, so now return to the grid on the right, and I point out the attention on the light session, because it's quite useful